throttle alert, then to idle. Okay, that's about idle there. Okay, so let's try the same thing again with the Cessna Caravan. So if you keep an eye on this top row of instruments here, these are our engine instruments rather. So we'll do the exact same test. We'll go from idle to max to idle again. So in 3, 2, 1, full throttle. So that's maximum, then to idle. I'm keeping an eye on this torque gauge here, by the way. Okay, that's idle there. Now, a multi-engine aircraft can use either piston, turboprop or jet engines. Most pilots learning to fly a multi-engine aircraft will start in something small such as a Beechcraft Baron, which uses piston engines. So using this plane as an example, let's have a look at some of the key differences compared to a single engine aircraft. So the most obvious difference is that you now have 2 engines instead of 1. This means that you have twice as many engine controls and instruments to keep an eye on. Here are the instruments for the left engine, and here they are for the right. If we have a look at the throttle quadrant, we have 2 throttle levers, 2 propeller levers, and 2 fuel mixture levers. Also looking at some of the other systems, you can see that we have a slightly more complex fuel system with a crossfeed function. Down on the switch panel here, you will find 2 engine starter switches along with 2 alternators, one for each engine. So let's look at a general comparison between propellers and how they work. So imagine you have a 2-bladed propeller here, and imagine that it's sat at one end of a block of jelly. When you begin to turn the propeller, it will actually start to pull itself into the jelly, if you can imagine that. Think of turning a screw into a piece of wood, for example. It's the same effect. It's this screw-like motion which allows the plane to move forward. Propeller blades are actually shaped like little aerofoils or wings. This allows them to better direct the air as it hits the propeller and create thrust. Now, to make the propeller more efficient, you can alter what's called the propeller pitch. This basically means the angle that the blade is sitting at. The propeller pitch can be changed during different stages of flight to make the engine perform better and become more fuel efficient. This is controlled in the cockpit using the blue lever that we saw on the throttle quadrant earlier. When the blade is close to being in line with the rotational velocity, this is known as having a low propeller pitch, or a fine pitch. This allows the engine to run at high speed and is mainly used for stages of flight which require the best performance, such as takeoff. When the blade is angled more steeply, this is having a high propeller pitch, or a coarse pitch. This is generally used at higher airspeeds, when the aircraft is cruising along, for example. There is one more setting that you might come across, and that is a feathered pitch angle. This is basically when the blade is turned edge on into the airflow to provide very little wind resistance. This is mainly used if the engine fails because it reduces aerodynamic.